Hi and welcome to Data Virtuality. In this video series, I would like to explore with you how to integrate your data in a modern way. So let's take a look. The first question is, why do companies move their data? Why are they using the ETL process to move their data to integrate it? The first thing they want to achieve, of course, is optimize their query performance because they want the data to appear on the dashboards very quickly. The second reason is they want to have a common query language to talk to all the data they integrated. And the third reason is they want to create a central data model for their business analysts. So what is the problem with that? There is a pain of moving this data. So according to Gartner, last year we have a failure rate of 77% for ETL projects in large companies. We have slow data to actionable insights, so it takes 6 to even more than 9 months until you can see the first data on your dashboards, and this is a lot of time for businesses. It is very labor intensive to set up and maintain your ETL process. So you need a high number of members in your team, and it's very costly to do this. And it's also inflexible. So whenever there's changing in business needs or changing in the data you're integrating, you need to modify the whole thing and you need to rerun the ETL chain in order to push the results to your dashboards, and this takes a lot of time. When you virtualize your data, for example using data virtuality, and you move it only if you need it to be moved, then you have a high project success rate. You have a good time to solution because this can be done in days, not in months. You have a flexible and adaptable data model that can be changed according to your business needs, so you can quickly react to changing in your business. And you can also set up ETL processes, ELT, and change data capture in an automated way. You don't need to do this manually. Let me now show you the architecture of our solution. Data Virtuality Server is a Java-based application server that can be hosted in the cloud or be run on-premise. The first step after installing Data Virtuality Server is to connect your data sources. We have connectors to more than 100 different systems, and as soon as you connect them, they can already be joined and are integrated in a scalable way. The next step after connecting your data sources is to create a logical data model on Data Virtuality Server. Since it does not rely on physical extraction of the data, it is very flexible and agile and can react to your business changes very quickly. With the logical data model in place, you can start using your data from the front-end side. You will see all your connected data sources as well as your data model from your BI front-ends and will be easily able to choose between different data sources and combine them at will. And this way you're able to use self-service BI. When the datasets you want to work with are too large for live querying, or you want to work with historical data, you can use the analytical database of Data Virtuality. It will automatically replicate your data and will then serve it to the BI front ends without you having to change the data model. This way you can choose between real-time data from your data sources or the high query performance and robustness from the analytical database. Let's take a look at Data Virtuality Studio. On the left-hand side, I have my Data Explorer, where I can take a look at all the data sources that I've connected, at all the virtual schemas I've created, and take a look at the analytical storage. In the middle, I have my working area, where I can work with SQL, inspect the data sources, or take a look at my schedules. On the right-hand side, I have my context-sensitive help, and on top, I have my control bar where I can access the various functions of Data Virtuality. So let's inspect this MySQL database that I've connected as a data source here. So let's click on Edit Data Source, and I can take a look at all the specifics of the database. And if I open this up, I can see here that there's 76 tables in there, and I can click on them and take a look at their definition and maybe at their indexes if I want to. Now, in order to call a simple select statement here, I can press on View Content, and it will show me the structure of the table here as expected. It's a MySQL relational table. The interesting part about data virtuality is that when I use this on a Salesforce data source, which is also very simple to connect, so I just need to enter my user and my password, it has the same structure. So I can see here there's tables as well, even though this is a web service. So we abstract from it. We use SQL to talk to this web service. And let's take a look at the contact table here. So I would just do the same thing. I would write View Content. We can see it took a little bit longer because there's a web service behind it. But in the end, I'm using the same SQL language to get data from Salesforce. I can also update here, so I can write to the Salesforce table. I could update my contacts if I wanted to. And let's take a look at the Hadoop cluster that I've connected. It's the same thing here. I'm using the Hive connector. And in the end, it's the same structure. So I see tables, and I can select data from them just as I would with all the other tables and databases that are connected. The same thing is now valid for MongoDB, which is usually a NoSQL database, but in Data Virtuality Server and in my studio here, it's presented to me in tabular format. So I can also issue a select statement that will get data from the MongoDB NoSQL database, but it will be presented to me as a tabular format. Let's take a look at the virtual schemas feature of data virtuality. First, we will create a new schema, and I will call it my schema. You can see it appearing here. It's still empty, so let us fill it with some data. So I will call the create view builder. The data will be put into my schema, and the view name, I will just call it product. Let's add some table. I will only add one table, which is in MySQL, and it's called product. As I'm creating a data model for my business analysts, I don't want them to be distracted by all the other data, so I'm just entering some data here, such as color, for example, maybe the dealer price and the list price. So that's all I need to do for my virtual view. Just opening this in the SQL editor, and you can see here the create view statement, which will put the view in mySchema.product and which will select some data from it. So let's just try this out. So I'm just selecting the select part, and you can see here the result immediately. So I don't need another ETL run when I'm working with my data model. I can just go ahead, write those views and test them. I'm putting an alias here for product ID, so I will call it product_ID, and I can test my modification instantly. I could also use any kind of different SQL here, so I could use an average or aggregation in the SQL dialect to work with the view, and the data virtuality server will perform this transformation. So I'm fine with the view as it's right now, so I want to run the whole statement, and now I've created this view in my schema, and we can see it's called product, and I only have these values in there. Let's now create another one. Let's create one with data from an Oracle database. So I'm calling the view builder again. This time I will call this view sales. Let's add some tables from Oracle here. So my Oracle database, and there's the sales order detail and the sales order header data. I'm adding this, so I can create a join here. By the way, I could create joins between any kinds of data systems here. Data Virtuality would join them automatically. Now I know that the sales order ID is present on both tables. So let's select them here. Let's select some data. So let's say I want the product ID, maybe the order quantity, and the line total. And from the header data, I want maybe the order date, and let's take a look at the subtotal, for example. That's all I need. Now I can also work with this view. I can try if it gets the right data. I still want to rename my product here ID as well. And I can again test see if it worked. Okay, this is the way that I want this to be. So I run the whole statement in order to create this view. Now I have a product and a sales view. I can take a look at the definition always. And I can also view the content here, so you can see this is a simple select statement that returns data from this view. Let me now show you what this looks like from the Tableau side. So we want to take a look at how Tableau is joining the virtual views that we just created in our data model here in my schema. So I'm moving over to Tableau. I'm connecting Tableau to Data Virtuality using our supplied ODBC driver. We see that there's username and password involved, so you can only see the data that is meant for you if you're using your credentials. We're signing in. You can see here that Data Virtuality acts as one virtual database to Tableau. And the interesting part is happening in the schemas. So I can see all the data sources that I've connected and also my own schema that I've just created. So we can see MySQL here as a database, and my schema is the schema I just created. So let's drag in the virtual views that I've created. Let's drag in the product view and the sales view. Since I put the right names here for the product ID, Tableau will automatically identify this as an ID on both sides and will create the join automatically. So I'm satisfied with the data model, and I can press update now to take a look at the data coming from Data Virtuality server. So this is now a join happening on the fly. So I'm joining data from MySQL and from Oracle, and Data Virtuality server is executing this join in memory as I'm requesting this data. Let's now go on and create a little report here. So I would like to know what products were sold and how much money was made with it. So this is my simple report. Let's now move over to Data Virtuality and take a look what happened there. We have an audit log, so we log any query that is coming into Data Virtuality, saying who issued it, when did it start, when did it finish, how long did it take. This is the query coming from Tableau, and I can take a look at the execution plan here. I can see there was data requested from MySQL, and there was data requested from Oracle. The whole thing was joined while automatically converting the product ID from MySQL to big integer in order to match it with the data format of the Oracle side. And we're using a merge join because we can sort the ID, the product ID, on both sides. Eventually this data was returned to Tableau. Now let's assume that this was a too long time. So let's assume that this took too long because there's too much data involved. So let's go to the optimization tab, a unique feature of Data Virtuality, where I can see all the joins being performed by my users. So we are counting how many times this has been used. And in order to optimize the join that was just taking place between product and sales, I can use the optimization feature, and I will just press enable and run optimization. Now we can see here there's a check mark coming up. It's not filled yet, so the server is actually copying the data from the data sources, is joining it, and it's putting it into the analytical storage. Now I can refresh to see if it's finished. We can see here this has finished. And now let's transform the report on the Tableau side by just entering for example, the order quantity into the report. And let's go back to data virtuality and take a look if the query has changed. So I'm refreshing here in my audit log, and I can see here that this is now only a table scan on my DWH schema, which is the analytical storage. So data virtuality identified the same join and took the optimized data from the analytical storage. Now this is happening much faster, so we get factors of 10 to 20 times by putting data into analytical storage. Let's explore the scheduling options of data virtuality. In order to do this, I take a look at my optimizations tab again, and I can see here I applied the optimization for this join coming from Tableau. And applying it means only a one-time download of the data and putting it into the analytical storage. Of course, I want to do this periodically, so let's add a schedule to it. I can see a variety of options here, so I can let this run only once. I can let this run at an interval of, let's say, for example, every hour or on a certain time each day, and some days in the week, some days in the month. I can even add my extended schedule here, so for example, add my cron expression, or I could chain this extraction job to another job. So this one could prepare my extracts, and I would chain it to the successful execution of this job running at 6 p.m. Let's just make this a daily job now that runs at 12 p.m. So I'm just finishing this wizard here. And now if I look into my Jobs tab, I can see here the recommended optimization appearing for the join. I can see that it's sleeping right now. I can see when it will run next time. I can see the schedule here. I can control it from here, which means, for example, I can just run it right now if I want to. And all the execution will be put down in my job history. So I have a log of all the jobs that were happening. And I can see here when they were taking place, when they started, how long they took, and if they were successful. Of course, I can get informed if the job is failing, so I can put an email notification here, can configure this, and I can say enable this, and if this job failed, send a mail to the recipient telling them that this failed, so they don't have to look at this job history all the time. Let us now take a look at the role-based permission system of data virtuality. In order to show this, I go to the service menu here and say manage users. And there's only one admin right now as user, so let's create another one. And give them, for example, already the data analyst role and maybe the export role as well. So I'm creating this user, and now I want to create another role for them. So let's create a role here, and let's call this the BI user role. And now in order to assign this role to my newly created user, I can just say add a new role here, and it will be the BI user role. And in order to access some rights to a role, I can go on a schema, for example, and I can say set permissions here. And let's assume I want to add the BI user role being able to read here. So I'm assigning the BI user role, and it will only have the ability to read from this schema. So I'm moving away all the other rights, such as create, update, delete, execute, alter in language. Only the read-write remains, and now users with this role will only be able to read from the My Schema resource. If we look at the query log of data virtuality, I can see here that all this has a corresponding stored procedure call. So I can also do this from the outside, and therefore I could, for example, export some users into a CSV file and re-import it on data virtuality from a CSV file. So this can be automated and doesn't need to be manually put into place using data virtuality. Let us now take a look how we can connect to a REST API web service. So the first thing we want to do here is add a web data source. So this is my web service data source, and in terms of data I would just call it general web service. And I wouldn't give it any endpoint right now or any security type, but we support, of course, HTTP basic, WSS security and OAuth. Well, we just keep this as it is and finish the creation of the data source. Now it's available to us, and we can now use this to connect to a web service. I want to connect to a currency exchange web service. I have the endpoint right here, so let's copy this. And let us use the wizard for XML and JSON, so both of those is supported. I would be going to a web service. Of course, a file source is also supported. I will use my newly created web service data source and paste the endpoint in here. Now everything else is good to go. I could, of course, use different kinds of requests, could add a request header and a request body, and the response can be XML and JSON, of course. Right now my settings are fine, so I'm just pushing on apply. So I can already see the structure of the data I'm getting, and you can see here what this looks like in the original. So I see on the third level of cube I get my currency and the current rate of today. So let's go back here and say, okay, I need the data from right here. If I go next, I can see the result down there already, but I still want to modify my data here because I know that rate is a float value, so I will just convert this to a float value. And now I can finish this wizard, and the result will be, as always in data virtuality, a SQL statement. So if I run this, I get the result and the current exchange rates for the euro. And if I want to put this into my data model, I can again create a view from it. I put this in the My Schema and give it the name euro rate. And if I run this, I have created a view that is querying the web service in real time when I'm executing this. And this is also available to my Tableau users, for example. So everyone using the data virtuality server will see this view, and you can view the content, and then this will just show the result of the web service being called. And this is how easy it is to connect to a REST API web service in data virtuality.